Today's topic is integration. We are going to have a tutorial about integration, and we are going to start with integration by partial fractions. Integration by partial fractions. Let's write the rules, the main rules that we are going to use. First of all, integration of 1 over ax plus b dx is equal to 1 over a ln ax plus b plus c. And the second rule is 1 over ax plus b to the power of n dx can be written as ax plus b to the power of minus n dx, which is equal to 1 over ax plus b to the power of minus n plus 1 divided by minus n plus 1 plus c. These are the rules that we are going to use today for integration by partial fractions. Example 1 to integration by partial fractions. A, write 12x over x squared minus x minus 2 in the form of a over x minus 2 plus b over x plus 1. Let's do part A, then do part, we are going to follow part A with part B. 12x over x squared minus x minus 2 is equal to a over x minus 2 plus b over x plus 1. So first step is to equate the denominators. I am going to multiply that one by x plus 1, that one by x minus 2. So 12x is equal to a x plus 1 plus b x minus 2. First step is to substitute x is equal to minus 1 to make that expression 0. So 12 times minus 1 is equal to, this becomes 0, so b times minus 1 minus 2. Minus 12 is equal to minus 3b, so b is equal to 4. Then we have to say that x is equal to 2. When x is equal to 2, when x is equal to 2, 12 times 2 is equal to a times 2 plus 1. 24 is equal to 3a, a is equal to 8. So let's rewrite that one. 12x over x squared minus x minus 2 is equal to 8, a is 8 over x minus 2 plus b is 4, 4 over x plus 1. And B, part B is going to be a integration question. Hence, or otherwise, find integration of 12x over x squared minus x minus 2 dx. So let's solve question B, part B. Instead of 12x over x squared minus x minus 2, I am going to write it as 8 over x minus 2 plus 4 over x plus 1. And by using that rule there, it is easy to see that we can separate these two integrations, take 8 outside of the integration, x minus 2 plus 4, 1 over x plus 1 dx. So this is equal to 8. We don't have any number there, it is 1, so it is 1 over 1 ln x minus 2 plus 4 ln x plus 1 plus c is the answer. That is example 1 for integration by partial fractions. I am going to send the picture to you by messenger and by WhatsApp. Wait a second, please. And I am going to erase the board for example 2. I think you don't have any questions here. This is a basic example. Now, example 2. Again for integration by partial fractions. Then we will do a couple of substitution questions, and those going to be a little bit hard questions. Yes. Example 2. Again, this is an example for partial fractions. Part A. Express 60 over x 2x minus 1 squared plus x plus 1 in the form of a over 2x minus 1 plus b over 2x minus 1 squared plus c over x plus 1. Solution. This is part A. 60 over 2x minus 1 squared x plus 1 is equal to a over 2x minus 1 plus b 2x minus 1 squared plus c x plus 1. We have to equate the denominators. I am going to multiply this one by 2x minus 1 and x plus 1, that one by x plus 1, and that one by 2x minus 1 squared. So 60 is equal to 8 times 2x minus 1, x plus 1, plus b, x plus 1, plus c, 2x minus 1 squared. Say that x is equal to negative 1. When x is equal to negative 1, that one and that one is going to cancel. So we are going to left with that one only. So 60 is equal to c times 2 times minus 1 minus 1 squared. So 60 is equal to 9c. c is equal to 20 over 3. And let's carry on. Say that x is equal to 1 over 2. When x is equal to 1 over 2, that one and that one is going to cancel, because when we substitute 1 over 2 there, that makes 0, that makes also 0. So A and C cancel. So we only left with B there. So 60 is equal to B times 1 over 2 plus 1. 60 is equal to 3 over 2 B. So B is equal to 40. And second step is going to be substitute the value of C there and also value of B there, and let's then find the value for A. 60 is equal to A times 2x minus 1 x plus 1. B is 40 x plus 1, and C is 20 over 3 2x minus 1 squared. So we know the value for B, we know the value for C. The only unknown left is A, and the easiest value for x to substitute is 0. Let's say that x is equal to 0. So 60 will be A times minus 1 times 1, 40 times 1, and 20 over 3 times 1. So 60 minus 40 minus 20 over 3 is equal to negative A. 60 minus 140 over 3 is equal to negative A. A is equal to minus 40 over 3. So let's rewrite that expression again by replacing the values for A, B, and C. 60 over 2x minus 1 squared x plus 1 actually is equal to minus 40 over 3, 1 over 2x minus 1, plus the value for B was 40. 40 times 1 over 2x minus 1 squared, plus C 20 over 3, 1 over x plus 1. Part B is going to be hence or otherwise find integration of 60 over 2x minus 1 squared plus x plus 1 dx. Let's give the answer here. Instead of that one, I am going to rewrite this whole expression by separating the integrations. This is going to be minus 40 over 3, 1 over 2x minus 1, plus 40, we forgot the x here, we have to write the x, plus 40, 1 over 2x minus 1 squared dx, plus 20 over 3, 1 over x plus 1 dx. And the answer for that one is minus 40 over 3, 1 over 2, and then 2x minus 1 plus 40 times 1 over 2, 2x minus 1 minus 2 plus 1 minus 2 plus 1, and the last one is going to be 20 over 3, 1 over 1, we have 1 there, and n x plus 1 plus c. So the answer, simplified answer, is going to be minus 20 over 3 ln 2x minus 1 minus 20 over 3 ln minus 20 2x minus 1 to the power of minus 1 and plus 20 over 3 ln x plus 1 plus c. So we have two of the same thing here. Take 20 over 3 outside of the brackets. We have negative, which means division. Ln, let's have a single ln. And minus 20 over 2x minus 1 plus c is the answer. Do you have any questions? I'm going to send picture of the solution to you. Up to here, we did partial fractions, then we solve the integration here. If you have any questions, you may ask. Yes. Any questions? Waiting for questions. If you don't have any questions, I will continue. So, no questions from nowhere. I am going to continue. This was the hardest question about partial fractions and integration. Now I am going to have some substitution questions. I am going to solve some integration questions using substitution. And I choose a couple of different questions about substitution. I am going to erase the board and continue with substitution method. Yes. Method of substitution. Integration by substitution. Example 1. Use the substitution u is equal to 2x plus 1 to find x under the square root 2x plus 1 dx. Here, if u is 2x plus 1, let's make x the subject of the formula, subject of the equation. U minus 1 over 2 is equal to x. And if u is 2x plus 1, du over dx is going to be 2. So du over 2 will be dx. Now, what was our question? Our question was x square root 2x plus 1 dx. This is a general example about substitution. This is an easy one. So I started with an easy one, then I will give a much more complicated one for you. In place of x, I am going to substitute u minus 1 over 2. And we know that 2x plus 1 is equal to u, so let's substitute u there. And we have dx there. And dx is du over 2 in terms of u. So, we have 2 and 2 there, which makes 1 over 4. We have u minus 1 there. And what is square root of u? It is u to the power of 1 over 2 du. I am going to expand that one there. And it will be equal to 1 over 4. And u times u to the power of 1 over 2 is u to the power of 3 over 2. And minus 1 times u to the power of 1 over 2 is minus u to the power of 1 over 2 du. Let's do the easy integration here. Add 1 to the power and divide by that number. U to the power of 5 over 2 divided by 5 over 2 minus u to the power of 3 over 2 divided by 3 over 2 plus c. This is equal to 1 over 4, turn upside down, 2 over 5 u to the power of 5 over 2, turn this 3 over 2 upside down, it's a division, make it multiplication, u to the power of 3 over 2 plus c. And we know u in terms of x, which is 2x plus 1, substitute there in place of u. That's the answer. A typical question about substitution. Now, again, take the pictures here, send it via Messenger and WhatsApp, then continue. Do you have any questions? Do you have any questions? No questions? That's good. I am going to carry on then. Yes. Erase the board. Have another question here. A much more harder one about substitution. Yes. Example 2. Use the substitution x is equal to 3 tangent u to find 1 over 9 plus x squared dx. This is 9. Now, here, we have to remember derivative of tangent x. What is derivative of tangent x? You have to know this by heart. What is derivative of tangent x? It is sec squared x. You have to remember this one from differentiation. So after giving the hint, necessary hint, let's carry on with the question. X is equal to 3 tangent u. So dx over du is equal to 3 sec squared u. And substitute x and dx there. And it is easy to see that dx is equal to 3 sec squared u du. Let's carry on with the question. We have 1 over 9 plus x squared dx. So this will be equal to 1 over 9 plus, what is x? X is given as 3 tangent u. So that is going to be 3 tangent u squared. And what is dx? Dx is given here. We already found dx in terms of u. It is going to be 3 sec squared u du. What is the square of 3 tangent u? We have 9 there. That is going to be 9 tangent squared u, and we have 3 sec squared u there. And this will be 1 over, take 9 outside of the brackets, and in the brackets we are going to have 1 plus tangent squared u, 3 sec squared u du. And what is 1 plus tangent squared u? Do we know the expression for 1 plus tangent squared u? Yes, it is sec squared. This is equivalent expression for sec squared u. So 1 over 9 sec squared u, 3 sec squared u du, and sec squared u cancel each other. We have 3 over 9 there, which makes 1, no, I think we had a problem with the internet, so I quit a little bit for a moment, then carry on. Here, let's revise once more. I took 9 outside of the brackets. We had 1 plus tangent squared u in the brackets and the expression there. And we know that 1 plus tangent squared u is equal to sec squared u. So I carry on with 9 sec squared u. Sec squared u's cancel each other. We have 3 over 9 there, which is 1 over 3 du, which makes 1 over 3 u plus c. Now we need to find u in terms of x. Remember, x was equal to 3 tangent u. X over 3 is equal to tangent u. So tangent inverse x over 3 is u. I am going to substitute there. This was given in the question. The answer is going to be 1 over 3 tangent inverse x over 3 plus c is the answer of the question, which is a little bit hard question about the substitution method. Do you have any questions? I am checking my phone. And if you want, instead of tangent inverse, you can also write the answer as 1 over 3 arc tan x over 3 plus c. These answers are equivalent. It's up to you. You can use both. If you want, you can use tangent inverse or you can use arc tan. Let's have pictures of the solutions. Now it's time to send the solution by messenger. Yes, these were examples for integration, and we mainly consider partial fractions, integration by partial fractions, and now we did two examples about substitution. One of them was the previous one, which was a little bit easier than this one. Now I use trigonometry in substitution, integration by substitution. Tomorrow's topic will be, we are going to meet at this hour tomorrow also at 6 o'clock, and I will do revision about by integration by parts, and couple of questions about volumes and areas. See you tomorrow. I think I tried to help you. That's the end of the video. See you. Bye.